About 15 minutes or a little more. I'll try to pick people who haven't had a chance to ask questions first. Good, go ahead.
Thank you. Great talk. Really enjoyed learning more about these rings and what you thought about that. So the hypothesis, or something that we would call a hypothesis that stands out to me in the Principia, is the one that the center of the planetary system is not in motion, right?
Mm-hmm. Yeah.
And that, I think, is one of the ones that you mean plays a role in combination with the parts of the theory already established to develop the theory further.
Yeah.
I guess your picture, you had kind of like theory in theory, which might suggest that it's used to develop yet another theory.
Right, yeah, that was probably
But this one seems to really play a role in the deduction of his theory of gravitation and of the planetary system. So I'm kind of wondering how you think that fits into the framework, the picture you've drawn. And I want to ask specifically, do you think maybe it's that what Newton meant by hypothesis when he downplayed their role so explicitly was not that kind of a hypothesis, was not the, let's take it for the sake of argument that the center is not in motion.
Right, okay, so I'll start with that last part first. That no, I think that by the time we're in the second edition and third edition of the Principia, I think he absolutely means to call that a hypothesis. I think that in the first edition of the Principia, book 3 starts with, 9 hypotheses? And that's very much in kind of the style of Huygens' work, where Huygens starts with a whole bunch of hypotheses. And I think that sometime in the editing process for the second edition of the Principia, he kind of went back and restructured that stuff. And I think he brought it into line with this framework. And brought it into line with his early methodology.
Okay.
And so in that point, he takes out the first couple of hypotheses. He ends up labeling them as rules. He relabels a bunch of the others as phenomena, and then that hypothesis, it remains labeled as a hypothesis, but he kind of moves it just to where it's introduced. And so I think that this kind of is much more in line with this. And so I think he intended to call that a hypothesis. I think that it fits what I gave as his definitions of hypothesis, because I don't think he needs it to be true or false. In fact, he doesn't even really think it's true, or he's not sure. But what it does is it simplifies the calculations for him. So it's something that, he could have assumed the opposite. But that would have made it much more complicated for him. It doesn't matter if it's true or false. So I think that, so I think it does sort of fit as a hypothesis, and I think it fits with my account.
But just a quick follow-up, so you don't think that the role of that is mediated by a query, like the other hypothesis?
No, I don't. Hang on. No, because he doesn't put any. Yeah, I don't think that would be mediated by a theory. No, by a query. I have to have a. No, that's interesting. No, I have to have a think more about that.
I'm sure you could always just make up a query that sort of.
Yeah.
Is this true? Question mark.
Yeah.
George and then Rob.
First, a lovely paper, but a couple of comments, and one is a personal, what I feel obligated to make. At the time Bernard wrote that introduction you described, he had never seen a Newton manuscript. In fact, it was 8 years before he ever saw a Newton manuscript. And he did change his views over the next 50 years. I can attest to that very strongly. Even with Howard, one can cherry pick some comments made early that I'm sure later, and I sure know it's true of me. The other remark is just starting with the second edition, as you say, you didn't list them, but there are 3 hypotheses. And they're all fairly clearly simply this is something from which I'm going to do some reasoning. The most dramatic one is the last section of book 2, where he stipulates what's now called a Newtonian fluid, a fluid which we would say shear stress is linear with velocity gradient. And there's no issue that he's putting that forward as true, false, or anything else. He's simply going to draw some conclusions from it. So, and that's classically what the word meant. The word began meaning a conjecture as an alternative to theory only in the middle of the 17th century.
Yeah.
So these are just clarificatory points, in no way disagreeing with what you said.
Yeah. I mean, I've really only traced the use of the term hypothesis through how the Royal Society were using it, so people like Boyle and what it meant in that context. But I know that, so I think this could genuinely be a case where Newton's kind of using the term initially in the Principia with a different meaning to the way that he uses it in the optical work, but I think that he kind of tries to bring them into line somehow with each other. That's my kind of...
All right, a quick remark. I don't have it here. Rob may actually have it on his computer. If you look at the dictionary that was put out that Newton contributed to, remember when we looked at them?
Right, yeah.
We
I could-
downloaded the hypothesis, and you should look at it. In fact, I'll send it to you.
That would be
It's
great,
quite,
yeah.
it's all over the place. You
That's-
agree?
Yeah.
Whenever Newton tried to define anything, it was kind of all
Well, this
over the
isn't
place.
him, of course. This
Okay.
is one of his followers
Oh, right.
who's in direct contact with him
Yeah.
in London.
Yeah, the phrase "at most probable,"
Yeah,
which you quoted from Newton, also occurs there.
yeah.
Most of what I said has been already said by George. I just wanted to say you could call this a general distinction, right, between what George just highlighted, between what's hypothetical and what isn't, what's actually warranted on account of its antecedents as opposed to being explored on account of its consequences. And the latter, of course, disqualifies all these theories about the nature of life from being seriously considered. Yes, we could adopt this theory and see what follows from it, but we can't regard that as having been established in any way. And I just wanted to add to that for the same reason, another aspect of what I think Newton means by hypothesis, which I think is implicit in what you said. By the way, I share George's high regard for this talk, is the notion that when something's hypothetical, it means all the alternatives, or at least some alternatives, or at least one, are equally probable, or at most somewhat less probable, but equally possible.
Right, possible, I think, is a better
Yeah,
word for
and
what's
like the
going on.
one,
Yeah.
like the hypothesis in book 3, right? It plays a role in the argument, but certainly the contrary of it is possible, and Newton isn't therefore prepared to argue for it.
Yeah, that's a nice way of putting it, thanks, yeah.
Mary? No,
please.
go ahead.
Hi, Christina, I really loved your talk. It kind of makes me, want to go back to Newton's optics and want to, oh my God, I have to read this because it's so interesting. So I'm just curious about something. It was the diagram that you had from Newton's optics. Maybe you can go back to it.
So which diagram?
Because I was trying to understand the one where he has the two, so where he has the prism or like the curved lens and then the plane, and there's a connection between,
This
yeah,
one?
this one, yeah. So I was trying to understand what's going on here. There seem to be, why does he draw the lines between, say red and then you have.
Oh, it's always red, have you noticed that? It's
Well-
always red.
It's red,
Because
but
he's
on the
marking,
other.
what he's doing is he's marking, this is, part of this, there's a whole other thing going on in here where
Okay.
he's trying to map this onto kind of harmonics. He's trying to give a
Yeah.
harmonic account of all of this stuff too. And so this is why he's kind of mapping the red each time, every time you see red,
Right,
he's kind
but you
of, and
see
he's
that
measuring the,
on one hand you have red and on the other hand you have green.
right.
So for me it wasn't like, so what you said, and I couldn't understand the diagram in light of it, was whether the red goes through or not.
No,
So I thought it was, now I looked at this, it's like, it goes red, but then it has to go a whole period, reach the green, so it reaches green again. It might reach one time or like go second time. Is that how he thinks about it?
yeah, so basically you're getting just these if you just look from, say, the top, what you're getting is you're just getting a repetition of the color you're getting like a spectrum of circles together and then another spectrum and another spectrum.
Right.
And they always come in the same order. And the point is that the different color, so if red is being reflected at the bottom,
Okay.
it does, so that's why it doesn't pass through at the same time. It can't do both things at the same time. It can't go through and come back on itself.
Okay.
Is that, I'm not sure if if I'm answering your question though.
I was puzzled about why you have the connection between red and green, right? Is it like, so why is that line, I mean, like, what's the correspondence? Is it supposed to be, you have a red light here, we have a red ray here, and then a green one on the bottom, or something else?
Yeah, well, so what you find is that, right, so you get that here, right, where you've got, where at that one point, all the light that's coming through here, the red light is reflecting, and the green light is being transmitted. Because they, excite the vibrations at different rates or something or other. Yeah.
Okay.
Yeah.
Okay.
But no, the main reason why he's trying to mark off these is because he's trying to figure out the harmonics, and he thinks that there's kind of a, there's what is it, a Q? There's a harmonic ratio here as well.
Okay.
Yeah.
And then,
At the, well, I already asked lots of questions, so I'm happy, I can ask Kirsten later and defer to
it's
the
still
details.
13 hours for thinking of your birthday, so.
So I also just thought this was a fantastic talk. I found the epistemic distinction among the three categories extremely useful for clearing up some things that I've been confused about in Newton for a while. But I am still confused about one thing that you put your finger on. Near at the very beginning, you said that certainty for Newton is compelled assent. That's how we should think about it, and that it's deduced from compelled assent by deduction from experiment, more or less.
Deduction or induction, or
Yeah.
the
Derivation in some sense from
Yeah.
experiment. And then but then you also you describe theories as certainly true.
right.
And theories themselves are also to be deduced from an experiment. And you were very clear to say that we should think of certainty as compelled assent and you said and nothing stronger. But then true seems like kind of sneak in for theories.
Yeah, I think
And
this
really,
is
that
me
kind of
not.
confused me.
He I don't think ever really. Well, in some cases he sort of talks about true causes and things like that. But yeah, I think I shouldn't have said certainly true, except that it's yeah. I think that's just kind of me saying that. But so I've sort of tried to figure out, because I think sometimes I talk about Newton thinking these things are true and other times certain, and I think these are two different things.
Yeah,
and
that's my sense, but I've honestly never gotten straight on the relationship between these two for Newton.
Yeah.
And so I was really hoping you would tell me what
Well,
you
right,
would
so-
tell me what it was.
I know that at some point I had there was one day that I was like, this is what it is, but I'm these things slip away. So but I think that most of the time what he's interested in is just certainty. So something like compelled assent, as opposed to kind of, I don't know. Does anyone else have any thought? All the other Newton people in the room, does anyone else kind of have a thought on whether there's kind of a kind of clear distinction between these things?
He wants to draw a distinction between geometrical demonstrations and then there's
Right.
as certain as the nature of things is meant to there's phrases like that he
Yeah.
uses frequently.
But does he use
And then I think
geometrical? Does he talk about truth in that context, or is that just because I don't think he would think that?
Well, this is a sort of distinction of different degrees of certainty, and then
Right.
I think, this is something George has emphasized, that a way of reading the rules is that you should take something to be true.
Okay, good.
That's his point.
Yeah,
how he phrased it.
good. Yeah,
So,
yeah. And so I think these two things sort of do come apart, and truth is not really. Am I right in thinking that truth isn't really the important thing? It's certainty that's the important thing somehow. If you're going to pull them apart.
In the
Something
Principia, talk of certainty just isn't there. And all I can say, Alan Shapiro has labored over what Newton means by certainty for the whole time I've known him and long before that. And it's very problematic.
But so aside from what Newton thought about it, what could compelled assent be other than rationally compelled assent, which would mean what you should be compelled to believe if you're rational, and then how could something be rationally compelled unless it's true?
He thinks that. So the way I think about it. So compelled assent, is the terminology that I use to explain this. So I don't think. So I don't want to say, I don't want to put the words into Newton's mouth, but I take it what he means is that so he thinks that he's got so take something like the experiment of Crucius, right? He's got this really good experiment that he thinks just kind of displays this phenomenon that gives you, you know, a property of light, that he thinks that just, if you carry out that experiment correctly, there just can be no other way of thinking about it than the way that he does. And I think that that's the kind of certainty that he thinks you have. Like he just thinks that if you don't believe, if you don't accept it, then you're just like, you just carried out the experiment wrong. You're just like, you've misunderstood it if you don't reach the same conclusion he does. I think that's, at least in the kind of optics, I think that's the kind of thing that he means by certainty.
And then if we got time to speak, then Bill after.
Thank you very much for your talk. I was wondering if you could say a little bit more about the distinction between explanation and theory. You say that ethereal vibrations help explicate the formal theory. So I was just a little confused about that and how, I guess, how Newton is placed within the background of what other people are doing, like the Cartesians, who I guess would involve the efficient and final cause kind of view.
Sure. So I think that most of Newton's contemporaries didn't take him to have explained anything by what he had done, at least in that first paper. You know, Huygens' response was, no, he hasn't explained anything until he's explained the nature of light. Because, you know, he hasn't given a mechanism for explaining what's going on. So, yeah, so certainly other people did not think that he had explained anything. And then, but Newton, I think this is where I really liked that quote I started with from Howard of the multiple visions, you know, multiply visionaries, yeah, where he kind of can explain, he kind of offers like a local cause, so a cause at one level that kind of explains things as far as you can explain them, and then part of the point of natural philosophy for Newton is kind of to keep on ideally digging your way down through the causes and offering deeper and deeper explanations for a thing. But I think that for him, he takes himself to have explained the elongation phenomenon at that kind of local level. And he doesn't think that there's anything wrong with that, but he also agrees that there are further explanations you could give if you know, if you can carry out the right kinds of experiments or something. Does that answer your question, Jim?
Can I quickly add just one point? This is for everybody's information. The word explanare, literally explained, does not occur in any edition of the Principia or in any annotation he made in any of his copies. He only uses explicare and explanare for what it's worth.
Okay.
Yeah, sure.
At some point, thanks for the talk. This may have been an errant comment. You said scholia play the function of queries sometimes? Could you
I
say
think that
more
they
about
do. So I think that generally the scholia in the Principia, he uses them, at least, yeah, so you know, you've got all these mathematical propositions, and then he introduces these scholia that kind of try and map the mathematics onto the real world. So it's usually in the scholia that he starts talking about, I don't know, you know, balls and buckets and all that kind of stuff. And then he kind of suggests experiments, or he describes ways in which he's seen things in the real world behave the way his mathematics says that they should behave, and so on. And so I think that those scholia are kind of doing that kind of role where they're kind of suggesting, they're offering research programs, ways that you could, you know, apply his mathematics to the world and kind of study things. Is that?
I guess at that level of generality, I would agree, but then it seems
keeping in mind that a lot of these are quite
the level is just
speculative.
too high, right? If queries and scholia are the same because they both talk about the real world, well, that's just way too abstract. But there's got to be, why didn't he label the optics queries scholia? Why didn't he label the scholia in other places queries?
So this is a good question. I mean, I think there's a lot of kind of, I think context is playing an important role here, where I think that the language, the way that he uses terms like query and hypothesis, I think come from him reading Boyle and people like that. And so it's obvious, it's clear that he should, you know, he just automatically uses that language when he's doing optics. But I think that when he starts doing, you know, the mechanics stuff, I think that he's being influenced by a very different tradition, at least kind of linguistically. And so I think that kind of as he tries to integrate all these things and sort of develop a unified method of some kind, I think that what we find is that these things are kind of playing similar functions in the two different cases.
Can I just
And-
add something to
Yeah,
that?
sure.
One sentence. He does explain in book 3 what the purpose was of all the scholia in book 1
Yeah,
and book 2.
that's right, that's right.
To illustrate, right? He uses that
Philosophical
language of the-
scholia to give examples of
Yeah.
abstract mechanical principles, or as what he calls
And that
mathematical.
fit, and that very much fits with the way you were.
Last
what I-
question, Bill.
Well, what I wanted was to find in, that Howard has in that 1990, in the paper in, where he does Newton's argument for universal gravity, talks about, I mean, he's focusing on deduction. And he's pointing out, do you remember, George, that the different, he defines the several. Proof,
Deduction and derivations is threefold.
threefold.
And he says book 3 as a whole is the deduction. I'll be talking about this in my talk.
That,
But everybody should know, he only uses the deduction in the general scholium added in the second edition. It never occurs anywhere else in the printing.
and it doesn't mean what we think of following logically, and this is what fits with this certainty stuff you were saying. It's a matter of, given the circumstances that say, if, given that you accept this and this, then you should be, then that would, it's called a deduction if somebody taking those premises would be in a position where it would be reasonable for them to conclude the conclusion. And it would be, and there's a little bit of, it would be pretty wild to not do it. That's there too.
Yeah.
Well, I think we should thank Kristen for a great talk.